So this is momentum, and we're going to be solving a AP style free response question. So for this question, we're told that a 500-gram cart rolls with negligible friction along a straight track until it collides with a 750-gram cart that is initially at rest. The position versus time data is shown in this graph, and so that's what we will be using to solve these questions.
At time t equals 2 seconds, the two carts collide in a perfectly inelastic collision. Calculate the final velocity of the 500-gram cart after this collision. So to do this, we'll have to calculate the initial velocity of the 500-gram cart. We can use the position versus time data to do this because velocity equals position over time. So we'll use the last point, 40 centimeters at 2 seconds. 40 centimeters over 2 seconds equals 20 centimeters per second, or 0.2 meters per second. Now to find the final velocity, we can set up a conservation of momentum equation. And because it's perfectly inelastic, we know that the two carts will stick together and both roll in the same direction. So mv1 plus mv2 will equal m1 plus m2 times v. So when you plug in the values for this, down here you get 0.5 for half of a kilogram times 0.2 for the initial velocity plus 0.75 for the 750-gram cart times 0 equals 0.5 plus 0.75 times the velocity final. When you solve for velocity final, you get 0.08 meters per second. Now it's going to ask us to graph the velocity versus time of this whole interaction. Velocity on the y-axis, time on the x-axis. 750-gram cart is the dotted curve, and the solid curve is the 500-gram cart. Since the 500-gram cart starts at 0.2 meters per second, it will be a constant slope from 0 to 2 seconds when the collision takes place. And because the other cart is at rest, it's a constant slope at 0 until the collision takes place. In the question, it tells us that the collision takes half of a second to occur, and then it will reach its final velocity. So our final velocity up here we found was 0.08 meters per second. So that's what the two carts will end at. And it will take half a second to reach that. So there will be constant slopes from the initial velocities to the final velocities.
So to determine the impulse imparted to the 750-gram cart, we need to use the equation impulse equals force times time equals mass times the change in velocity. So for this, we'll use impulse equals mass times velocity final minus velocity initial. So for that, we'll get 750 or 0.750 kilograms times 0.8 meters per second minus 0 because there's nothing on the initial. And so we'll get impulse equals 0.06 kilograms times meters per second, or 0.06 newtons over seconds. So in this question, to determine the magnitude of the average force acting on the 500-gram cart during the collision, we'll use the equation impulse equals force over time, or force times time. And so we'll use the impulse we found earlier for 0.0 newton seconds equals force times 0.5 seconds. So then we divide over the 0.5 seconds and we get 0.12 newtons as the average force acting on the 500-gram cart. All right, so in this question, we need to calculate the velocity of the center of mass of the two-cart system before the collision occurred. So the velocity of the two-mass system is the same before and after if there are no external forces. So we know that the velocity of the center of mass after is 0.8 meters per second. So that also means that it was 0.8 meters per second before, since they will be the same.